The formula we've learned in the previous video, video 19, we have found that if we have discrete data that follows each other, then you can use this formula for the expected value of x, and for the variance you can use that formula. But you do not have to prove these results, or you do not even have to know them during examination and for examination, but you may find them useful in answering some questions, and especially what comes in our very last example in this chapter, example 18, that is asking us, digits are selected at random from a table of random numbers. Digits, they are selected at random from a table of random numbers. Digits. Find the mean and the standard deviation of a single digit. The mean and the standard deviation of a single digit. That's where we should begin. That's part A of our question. Find the mean and the standard deviation. And of course, as we know, digits are single numbers. In this case, the digits will be the numbers between 0, that is a digit, there is a 1 a digit, 2 a digit, 3 a digit, 4, 5, 6, 7, 8, 9. All these are digits. But if we try to position them, we will call them digit number 1. This is digit number 2. This is number 3, number 4, number 5, number 6, number 7, digit number 8, digit number 9, and digit number 10. So they are 10 in number. Of course, we have two different information. Of course, we now have to categorize each one of them in their right place and say, let R represent these random variables having a discrete uniform distribution over the set. Let R be represent this random variable having a discrete uniform distribution over the set 0 to 9. So this is our R. R represents the digit from 0 to 9. Let X represent a random variable having a discrete uniform distribution over the set 1 to 10. This is our X, because as much as you're going to have 0 as a digit, 0 is going to be digit number 1. So the positioning of the R is what is being represented by X. And therefore, there is a simple relationship between X and R. And we can already see that if you want to get R, you have to have X minus 1. Such that if you are referring to 0, then 0 is 1 minus 1. If you are referring to 1, then 1 is 2 minus 1. In the same case, if you are referring to 9, then 9 is 10, which is X minus 1. That is the simple rule that combines the two. By introducing the random variable X, you can use the standard formula above, all this formula, for X with N is equals to 10. Of course, now, when we want to talk about the very first part of the question, find the mean and the standard deviation of the single digits. Now, the mean is the mean of R. And the mean of R is easily the mean of X minus 1, because R is X minus 1, which is, from many practices we have actually seen, that this one is going to be 1, the mean of X, 1, the mean of X, which is going to be 1 times the mean of X, of course, minus 1. But from this, we can highlight this and use it this way. That means what? EX is equals to n plus 1, whereby our value of n is 10 plus 1, because we have 10 we have 10 numbers here, 10 positions from 1 all the way to position 10 divided by 2. And of course, after we are through with this, then we subtract 1. And this one is just 5.5 minus 1, which is 4.5. And by extension, that is the expected value of R. What about the variance of R? What about the variance of R? Because we are told that find the mean and the standard deviation of a single digit, and single digits are just R. So exactly. So what we need to do now is we first of all find the var of R, and the variance of R is the variance of x minus 1, which according to us is simply the variance of x, because 1 squared is just 1. If once we get here, then we can easily use this arrangement. We can easily use this arrangement. Not that we cannot use the other method that we've learned, but we are just trying out this new formula, which is, of course, we are going to talk about n plus 1, which is 10 plus 1, 10 plus 1, multiplied by 10 minus 1, everything over 12, and this is 11 times 9 over 12, which should give us, obviously, 8.25. And that being the variance, this is the variance of R, which should be equals to 8.25. But the standard deviation of R is the root of 8.25, which is the root of the variance, which gives us 2.87, of course, to 3 significant figures. And in a nutshell, we can simply say that the standard deviation, this is the symbol of the standard deviation, is 2.87 to 3 significant figures. And that is it. That is how easily we can be able to use this formula as introduced in 8.11. But let's look at part B. Part B of the question tells us, find the probability that a particular digit lies within one standard deviation of the mean. Lies within one standard deviation of the mean. First of all, we must acknowledge our mean as 4.5. Even as I wrap this part, please note that the mean is 4.5. And let's talk about the mean. The mean is 4.5. Keep that in mind. And the question is asking us, find the probability that a particular digit lies within one standard deviation of the mean. What is that question asking us? That whatever number we are looking for must not be one standard deviation far from the mean. So, even if we are having our mean there 4.5, then from this particular point, we must talk about the standard deviation, which is 2.87. The number we are looking for must not be more than one mean below 4.5 and or one mean above or one standard deviation above the mean. So if you look at this arrangement, because that question can sometimes be confusing, if you listen to the question again, find the probability that a particular digit lies within one standard deviation of the mean, either below the mean or above the mean. But we should not go beyond one standard deviation. So we are saying it is 4.5 minus 2.87 That should be our lower boundary. Our lower boundary should be 4.5 minus 2.87, which should be 1.63. Let's talk about, this is our R, this is our R, which is less than or equals to, again, 4.5 plus 2.87, and this gives us, it should give us 7.37. Fine. If that is true, then this question is easier to deal with, because we need to get the probability of any number that lies between this lower boundary, this is the lower boundary, and this is the upper boundary. Incidentally, we are dealing with discrete data, where 1.63, as much as it is a boundary, it is not going to help us here, because it is not discrete, it is continuous. And even the upper boundary is still continuous. So it is above 1 and below 2. So the real numbers that we might accept, we are going to accept 2, we are going to accept 3, we are going to accept 4, we are going to accept 5, we are going to accept 6, and we are going to accept 7 itself, because the upper boundary is at 7.37. But 7, which is discrete, is right within our range. So what is the probability of finding of our number being any of these? And we have how many numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The probability of getting any of this is 1, 2, 3, 4, 5, 6. The probability of whatever our question is of 2 R, because now we can only accept 2, less than or equals to 7, is actually 6. 1, 2, 3, 4, 5, 6. 6 out of 10, which is easily 3 out of 5. And that is our final submission. It is true, this question is tricky, but you only needed to understand, find the probability of any number lying within one standard deviation of the mean. Understand, it is either below the mean or above the mean, but not beyond one standard deviation. And standard deviation is 2.87 and 2.87. I've explained everything, and these are the numbers expected. And write yes, that is the probability. And we've come to the end of the topic. As you revise, good luck. Any question, please, you may contact me, and I'll be glad to help you. All right?